just before we started recording, I sprung this on you to figure out or to run a test how long our unit tests take to run on your machine.
Right. Yeah, and it took me way too long because I didn't realize that. Is that a new thing with Swift testing, that it no longer crashes when or not crashes, but no longer fails when the database is not running?
I think that's due to the way I changed the with app thing. You know, the way it required changes
right.
in the transition to Swift testing. We can't use the normal setup anymore, and I think the new setup is different in that it hangs and doesn't crash. I forgot to add a timeout. That's about to change anyway, so that's an unfortunate side effect of the new setup right now.
By the way, is this
the show? This is the show. We are doing a live reveal of improvements.
It was just the way you talked about the with app thing was with no context, so nobody will know what what that is.
Just imagine there's some hugely complex thing that's happening, and it's happening differently.
To give a very, very brief bit of context, we have we've as we talked about last episode, we've recently switched the project across to Swift testing, and it used to be the case that if the Docker container with the Postgres database that we used to run our database tests was not running, a test would fail, and you'd know whether it was, well, the first thing you would do is you'd spot that it was a database connection error and you'd go launch the database. But that is no longer the case due to, the as Sven was saying, the new way that we're setting up the test there. So the very first time that I ran it, it took about 20 minutes because the database container wasn't running.
After how many minutes did you think something was wrong?
Well, I was doing other things at the same time, so I came back to check on it every now and again. So, but yes, with Xcode 16.2 and the no parallel flag passed to the tests, it was 40.6.
So the reason I'm asking is, as we talked about last time, one of the reasons in switching to Swift testing was that it will allow us to run the tests in parallel more easily, I should say. And I said that last time. All this would have been possible with XCTest. It's just a lot harder to do with XCTest. So we used the opportunity to transition to Swift testing as a prerequisite to do the parallel testing. And the reason I'm asking this question, how long it takes for you, is to give you a really nice surprise in how fast it could run with the new branch that we have in the repository where parallel testing is active and working.
Fantastic.
And you'll be delighted to hear that I think you run this on a MacBook Pro, don't you?
That's correct, yeah, an M1 Max.
Yeah. So on my M1 Max MacBook Pro, the tests now run in under 8 seconds.
Wow.
And that's by running against 8 databases in parallel. And there's really very, very additional performance to be gained if you increase that number. So 16 is effectively like 7. I mean, you might get half a second faster, but there's really nothing to be gained there. It's slightly faster still on the Studio, but also more databases don't help a lot. But on the Studio, I can get it to run in under 6 seconds with 16 databases under 5. I actually, first time it ran that fast, I thought, well, is it skipping tests? But it's not skipping tests. And I'm actually surprised that it takes 40 seconds for you running normally, because it takes. Actually, there's a huge spread when you run it normally on a single in a single test. I have 35 seconds is the fastest, but I've also had it run 51 seconds. So the jitter is really quite large when you run the tests like normally, consecutively, serially. What I found really interesting is the parallel testing. They are super consistent. So I get 5.6, 5.7, 5.7. It's like they don't jitter. There's a jitter of less than half a second between iterations. I guess that goes down to like it being really well utilized.
Interesting.
And the way this is set up is that we spin up a fixed number of databases at the start of the test. And in this case, n is 8. And then the database tests, so not all tests have to go through this, but the one that need a database will check against the database pool if the database is available. And if it is, it'll retain it, it'll sort of grab it from the pool, run its tests, and then after it's finished, return it to the pool. And if there's no database available at all, a test will just sleep for 100 milliseconds and then check again. So it is sort of a polling mechanism, but it works well enough, and they're not, they're not churning a lot. And that's the way that works.
And is there a lot of complexity? Is there a lot of complexity in the code for that?
Actually, there isn't. No, it's a single database pool actor that I added, and in the with database tests. So the thing that we had to introduce to make the database tests work with Swift testing, it really just asked the pool, give me a database, and the pool will just block and only return once the database is there. And that makes it really easy to swap in with the existing test runner.
The test itself doesn't need to be aware of that happening.
No, there's no change within the test at all. So the only thing is changed is in our all tests suite. At the start, we set up the pool, and we tear down the pool optionally afterwards. So that's the only change. There's really the tests have not changed at all. I mean, obviously, the only thing you do is you let them run in parallel, right? Because they can't run serially with that system. It could be made to work serially, but I didn't bother figuring out why that's not working. So the flag -- parallel or no parallel is really how you control if you run against the pool or not. So it's been quite. It's been fiddly, but it works really well, and it's really stable. I think the biggest problem was that we had, as you can imagine, when you have a test suite of almost 800 tests that have always run sequentially, you will find stuff that is inadvertently not be made to run serially. So there were a couple of cases where we, for instance, had metrics and they were always running serially, so they couldn't. There was no crosstalk possible. Metrics is our system of having counters, like request counters and stuff like that. And we have some tests that check that request counters are incremented properly. When tests run serially, you can just take the delta and you're fine, even if there's crosstalk. Now, suddenly, with parallel testing, it would happen that different tests would increment counters, and then the tests that actually look at the counters had wrong counters. So there were some parts in the test setup that I had to make sure that we keep separate. Make sure that they're thread safe, and adapt that. That was pretty much the work that had to be done to make this work reliably. And other than that, it's gone well. The only remaining issue is, as you can imagine, stuff like that is always harder in CI. I found out some weird stuff about bringing up additional databases in CI. They weren't discoverable as I thought they would be. Like the ports weren't mapped as I thought they would be, and there's a bit of work left to be done to make sure that the tests. Because when you run it locally, I use Docker commands to actually find the databases. It just runs Docker PS and then looks, and we have a certain naming scheme for the databases, and then it can automatically discover what databases are there. Now, our CI doesn't have Docker, so it can't use that mechanism. So you have to sort of prepare a set of databases where you sort of know the names in advance, and then it's more fiddly. Right. And I completely forgot that we don't have Docker, and we probably could make Docker available, but I don't really want to go down that rabbit hole. I probably just use the hard-coded names and make it work that way. But it's even debatable whether in CI we gain all that much, because the build takes 12 minutes in CI and then the tests take another 8. We can probably get the 8 down to maybe 1 or 2 minutes in CI, but you can see immediately 12 versus 14 minutes, 12 versus 18, 20 minutes. the gains aren't as much as like locally running the tests in 7 seconds is a huge difference to 40 seconds, right? That's going to be a big difference
right,
to
of course,
quickly
yeah.
run them all. And I think that's the main benefit we'll get out of this for our day-to-day work, really.
Well, you know what this means, don't
you? No.
we need to write more tests.
Well, we always need to write more tests. I thought I was bracing for something terrible, but I'm totally on board with that.
No. Yeah, we need literally double the tests because we need something to keep us busy. What are we going to do all day if we can't run?
No
the
more
tests?
Excuses skipping tests because they are using the database and might be slow.
Exactly. Yeah, exactly. That's great. I'm happy to hear that. It's a shame that the CI won't be quicker because that is so slow that it's a problem. But it's not an enormous problem. But I certainly don't ever wait for CI to run. I immediately go and start something else.
Yeah, that's the pain. And I think we'll when the Swift syntax being part of the toolchain will probably make the biggest difference there. That should shave a good 5 minutes off the build, I think.
Right. Mm-hmm.
For the tests. So I'm hopeful that we'll gain something, and then we hopefully end up under 10 minutes. That's my hope in the near term.
And I'm going to slightly change the subject now, but that change to Swift syntax is what's needed to make macros also quicker to use and run, right?
Yeah, exactly. Right now, as soon as you use a macro or use a package that uses macros, even if you don't use the macros, you end up, I think even if you don't use macros, you end up building Swift syntax as part of your build. And that's that adds a lot to your normal builds and to your release builds as well. But that's a separate pipeline for us. So yeah, great savings there on the horizon.
So one thing that that struck me as I was searching for packages for this episode was I'm seeing more and more, and I've seen this for a little while now, but it really struck me today. I'm seeing more and more packages that say Swift Package Manager only, no installation instructions or anything like that for CocoaPods or Carthage or anything like that. And I mean, that's no huge surprise because it has, Swift Package Manager has now been around for and usable within iOS and Mac OS projects for several years. I think, more than 5 years now. It's been in that state, and so you'd expect adoption of it to be to the point where people might not bother with CocoaPods. But I thought, as I kind of had this thought, I thought it might just be worth reminding people. I know we did talk about this kind of in the middle of last year. When CocoaPods made an announcement of what their support and maintenance plans were, but I thought we'd just kind of, it would be useful just to recap that. And actually, since we last talked about it, the CocoaPods team have put together a timeline for the shutdown of CocoaPods. So it's going to be no surprise to most people that CocoaPods will shut down at this point. I think the writing has been on the wall for quite a while that Swift Package Manager is going to be the way to include dependencies in any type of Swift project, whether it's server-side or iOS or macOS or whatever. And it's always good to know that timeline. So in January, so the basic timeline is this. In January of this year, an email went out to people who had contributed a pod spec, so any package authors basically, and they're going to be, or they were informed that the CocoaPods repository was going to switch to read-only with a link to the blog post. Nothing now happens until almost the end of next year. So September, October 2026, another email will be sent out to everyone who has contributed a pod spec, and saying that they basically have a month before a test run of going read-only. Then in November 2026, there is going to be this test run, giving automation a chance to break early. So Auto says, who's the person who wrote this post, Autotherox, and so he has a good test for everything to break, and then it will be made not read only again, and then finally in December next year, CocoaPods will become read only and effectively shut down at that point. It will still be available, so none of your projects that use CocoaPods, if you have any left, are going to break, because the pods will still be able to read, but you won't get any updates, you won't get any new packages or anything like that. So it's always worth being aware of this far in advance, and you've got at least 18 months if you do still use CocoaPods to basically make that switch to Swift Package Manager.
Right. Remind me, I'm always unsure. You still need it actually on iOS, right? If you wanted any sort of package management, right, other than pulling in libriries and
you need CocoaPods.
Yeah, but Carter, on iOS, you can't SwiftPM can't build an iOS application from a package manifest.
SwiftPM as a build tool can't build it. No, that is correct. But Swift Package Manager through Xcode or Xcode build can.
Right. Okay. Yeah. Got you. The package management part it can do, but it can't build the actual final product, because
it can't do the actual
you can't
build.
express it in the Swift package manifest. But Xcode obviously has a project file that can. Okay. Yeah.
Exactly. And again, this is the kind of thing that will go away with the new build system, which is coming, because it's a confusing situation that we're in at the moment, where we have two build tools, to different package management tools. Yeah. It will be great to get all of this on a single happy path through. If you would like to make an application, here is the build chain and dependency chain that you can use to do that. So I'm very much looking forward to that problem being solved. Yeah.
Yeah. And to have like a one-to-one answer, like a one-to-one mapping. This is the command line you would use to do the exact same thing. Yeah. And right now it kind of depends, there's two ways of doing it. And well, on iOS there isn't, but on macOS there kind of is, for depending on what kind of thing. It's complicated.
It is, and it shouldn't be. It really shouldn't be complicated. This bit should be the easy bit.
Yeah.
And I'm confident that we said this last time, but I'll reiterate it. I think the tremendous effort that went into CocoaPods over the years absolutely has to be acknowledged as an outstanding piece of open source work. They took what was an extremely difficult task. I mean, we think it's difficult now. Before CocoaPods, this was Git submodules and source code, and they took that process and made it just, possible for most people to do. And I think the way that project was run was always exemplary, and the support that they gave, and I just can't say enough good things about the work that everybody who contributed to CocoaPods over the years did.
Yeah, and quite a challenging thing also, because the upstream can change under you, right? You're always sort of chasing new Xcode releases and, stuff that might change in certain ways. And I find that super hard to have to track that.
And I think that consistency with how they're maintaining this has gone right through to the shutdown plan, which is 2 years notice of a shutdown plan, which is fantastic,
Yeah, absolutely. There's commercial products that get shut down faster, right?
Exactly. And I was going to say there can be so many products that in the commercial world that just disappear one day. They lose their funding, or they decide that it's no longer worth it, and then the next day they stop.
Yeah, exactly.
So that's just if you still have any projects that are on CocoaPods, make a plan to switch across to Package Manager.
Yeah, now's a good time. Right, there's another bit of news I saw on the social networks. A post on Mastodon about the value of open source software. I'm not sure if you've seen this one. It's a Harvard Business School and University of Toronto study to quantify the value of open source software. Did you catch that one by any chance?
I didn't. No, that's news to me. Yeah.
This is, as you can imagine, a interesting question, but also a very difficult question to answer, right? What's the value of open source software? This study is attempting to quantify that. I've read the paper. It's as messy as you can imagine. There's a couple of different data sources that have been used to try and get a feel for how to answer that question. I'm not sure how much to go into the details. It's an interesting read. I think it's probably best to focus on the takeaways. So their approximation is there's a $4.2 billion value in the initial value of the open source software, and the value to the companies actually using it is actually much, much higher. So that's estimated at $8.8 trillion.
Right, of course.
And the difference, as you can imagine, so the way they actually determine the value, the created value, is by doing a labor cost replacement estimate.
That was going to be my next question. Yeah.
Yeah. So what they're effectively doing is they're looking at the lines of code in packages, and there's another study that sort of has established a formula. it's a big name for multiplying a few numbers together, but there's a formula to get to a value from a number of lines of code. And what that tries to do is estimate, well, if you had to re-implement that, how much would that cost? And that's the 4.2 billion. And it's worth noting that this is pretty much a lower limit, because they only looked at a smaller section, and they left some open source software out of the picture entirely, like, for instance, open source operating systems, which are not insignificant. We're not part of the study, so you can already see, this is
in fact extremely significant.
Yeah, kind of, right? I found that curious why that isn't part of it, but you have to start somewhere, I suppose, and you have to at least do the bits that you can do. I guess that was perhaps the approach there. So they arrived at that, and then I don't know how they arrived at the multiplier, but effectively, so there's two ways of looking at the value created for the companies. One is if you lost all open source software and then it was recreated in an open source fashion, then it would be just 4.2 billion, and everything would be as before. But obviously the multiplier comes in if every company had to actually re-implement all the open source software they're using again internally, right? And then you can see, like, obviously, n companies doing the same thing will multiply that by n. That's how you arrive at high multiplier from 4.2 billion to 8.8 trillion. So that's that. I thought it was interesting, also interesting to see, and maybe as an incentive for companies to look at that and see, be yet again reminded of the value they're reaping from open source software.
And that's the problem with any story like this, is it just doesn't get enough publicity. So nobody who would have the ability to pay any of that money will ever read that story.
Yeah, I mean, absolutely, right? Because
which is unfortunate.
It's free, right? It's so hard to compete with free, and
it just doesn't. Well, and also it just doesn't even get discussed in that context. It doesn't enter the conversation in that context.
Yeah, it seems like the paper hints at it in a couple of places that countries or economic blocs like the EU are getting increasingly aware that open source is kind of infrastructure, and they are starting to fund open source and see it as a means of funding, because it's like building roads. It's like building like literal, like virtual roads that are used by, just like roads help your companies move goods, so does open source software help companies move data and do their stuff, right? So there's a incentive for economic blocs to help fund open source software. Perhaps at some point in the future look at getting specific diverting taxes towards that, perhaps. You can imagine all sorts of things,
right?
Where revenues or income in certain areas that get diverted or get put into pots of funding for these sort of programs to help. Because there's other interesting stats that came out of this. Like 5% of open source authors create 96% of value, at least of the parts that they looked at, which is extraordinary, right? That's an amazing figure.
Of course, yeah.
And on the other hand, it's very tempting to shoot down a paper like that and say, well, how could that ever be correct? But I'm not even sure the point is to be super correct, right?
No,
it's to get
no.
You need to get a baseline, right?
It's to make a point.
Yeah. You effectively you underestimate, and I think that's really important. It is wrong, but it's going to be wrong in a good way, right? You're not overestimating the value. You're clearly underestimating it. So you're sort of setting a lower bound for what the value is, and that's already tremendous value. So it gives you all incentive to help fund it further, right? To push this forward. Because there was a formula in there that sort of converted lines of code into effort, I of course took it as gospel and took our 50,000 lines of Swift that we have in the Swift package index, and apparently there's 18 person years of effort in it. Now, given that Swift package index is 5 years old and we're two people, that's 10 person years. That basically means we're two ex-programmers, right? We've beat the algorithm there.
What I was going to wrap it up with, but you've made the perfect ending there. What I was going to wrap it up with was, if we write more tests, we're worth more money, right?
Oh, absolutely. that's the other thing.
If we double our tests, yeah exactly.
And also, now that you have a formula that converts lines of code into effort, you know how you often asked, well, how long is this going to take? Now you don't have to answer how long it's going to take. All you need to figure out is how many lines of code will you need, and then you can convert back. That's amazing, right? Estimating will become so much easier. It's amazing.
Easy, yeah. Easy. Fantastic. Shall we move on to some packages?
Let's do it.
Do you want to go first?
I shall do so. My first package is called just Codable. Codable, not just Codable, but you know what I mean. It's by Andriy Chernenko. And I've seen a few of these. It's using macros to help you with the Codable implementation. I think we've even talked about a couple of these in the past. The reason I wanted to mention this one in particular is that I saw it has a @memberwise initializable macro as well, and I thought that's not something I'd seen before. That probably exists, I just hadn't noticed it. But what that does is it allows you to tack that onto a struct, and then it will auto-generate the public the initializer. And the reason why that's nice is because you can then just tack public in front of it, and then you don't have to, generate it yourself and maintain it in particular, right? You know how often it's really tedious to have a struct that suddenly needs to be public, because then you need that initializer.
Yes.
And that is then fiddly because, yes, you can auto-generate it once with the Xcode refactor tool. But that does it once. If you add properties, then you need to go in and add the properties. And this is nice because you can just tack this on and you don't have to do anything with it. It'll always be in sync with your properties. So I think that would be even nice to just have as a standalone package. And I also wanted to mention, while talking about this, there's currently a Swift forums thread about the future of serialization and deserialization, which talks specifically about using macros to do effectively what this package is doing. So this is on the horizon to become a proper, a foundation, I guess, or at least Swift standard library thing at some point. So the codable thing will sort of transition at some point. All these packages will sort of be, I guess, Sherlock by the standard library. But this member-wise initializable thing is definitely a nice thing that might then survive in a separate package.
Sure. So do you know how well I know you? I spotted that package. I thought that sounds interesting. And then I thought, Sven's probably going to pick that. So I put it on my backup list.
Thank you.
You didn't let me down. My first one is a package called Aesthetic Text by Kyle Bashaw. And I talked about this a little bit in iOS Dev Weekly, but I thought it was worth mentioning here too, because there's a couple of interesting things about it. First of all, I think the package itself is great. What it does is it's a SwiftUI package. It's a view modifier that you can add to any SwiftUI view, and you just tack on the end of any text view the view modifier aesthetic text. And what it will do is it will very cleverly work out where the line breaks should go in any text that was passed to it, so that each line of the text is approximately the same length. So you never get one line that's very long followed by a line that's very short, which is a common UI problem, especially when it comes to text that is centered in the middle of a view. So if you have like a empty state view or something that has some centered text in the middle of the view, having different length lines looks really awkward. So that's what the package does, and I think first of all, I think that's just a really great little tool that you can use to add polish to your apps before you release them. But also, and in relation to my next package, which we'll talk about in a minute, this is a great example to me of a package that is UI based, which a lot of people are wary of adding UI-based packages, but it's the kind of package that if it ever did get abandoned, or if anything did happen to it so that you couldn't use this package anymore, removing a package like this would be super easy, because all it would do is put the text back on to uneven lines, which is slightly less polished, but not the end of the world. And I thought it was worth mentioning for both those reasons.
I think where this is also great is in a localizable context, because you might do the proper line breaks in your primary language and then
of course
forget about all the other languages that have potentially quite different word lengths and stuff, and sentence structure and have quite different layouts.
Yeah, of course. Yeah, that's great. That's a great point. Really great point. So that's Aesthetic Text by Kyle Bashaw, and it looks great. There's also a great screenshot I love people who put a good screenshot or even a video in their README files. It's always good to know. I quite often, when I'm looking through package READMEs for preparing for this podcast, if a UI library or something related to the UI doesn't have any kind of screenshot of it, I'm afraid, rather than pursue it, I just close the tab.
Well, you'll be happy to know that this is the fourth on my list, and I put it fourth because I kind of expected you to talk about it.
Because you knew I would pick it. Well, I'm glad we're both living up to our reputations.
Yeah, there we go. We have nicely segmented into certain package picks.
Exactly, yeah.
Although we might have a conflict coming up. Let's see. I sort of suspect we have.
Okay.
We picked one that we both...
Setting up a suspenseful finish. Yeah, exactly.
Yeah. I don't think the second one falls in that category. That's called Artisan Standalone Swift by Josip Kavar. So this one is a bit difficult to talk about. So I think this is actually a Vervasoft software pick, one of Dave's picks. You, in all likelihood, you won't need this package. Very few people will. It's a fascinating package, though. So this is a package that uses a feature of Clang, and the feature is the real-time sanitizer. Now, most people will probably be aware of the sanitizers in Clang that we use commonly, like TSAN, which is the thread sanitizer, and ASAN, the address sanitizer. And what these two do is thread sanitizer to highlight cases where you might have race conditions and stuff like that. Concurrent access to shared data structures, and ASAN is where you write over address space, stuff like that. And this is sort of similar. It uses a real-time sanitizer feature of Clang where methods or functions have been annotated with a non-blocking attribute in Clang. And what that means is that they have a deterministic execution time guarantee. So they will return like deterministically. They won't just hang. And what that means is if you annotate, so this package comes with a binary library and a macro, which you can add to a function of yours. So you can say add non-blocking as a annotation. And then what you're expressing there is you don't want this function to call any blocking API. And blocking can be stuff you don't actually, I mean, when I saw the example print is actually in that context a potentially blocking API, because under the hood it might actually hang because certain buffers are full or something. You know, there's no guarantee on the operating system level that print will actually return deterministically. And there's lots of malloc and stuff like that, are all functions like that. So if you have code that sort of needs to have certain real-time guarantees, needs to finish in a certain deterministic execution time, you can tack this on. It'll give you runtime. You can configure what it'll do. It'll either trap and give you like a printout, or it'll run and at the end give you a summary of cases where you've actually called API that didn't meet that guarantee. I found that really fascinating, that you can expose that sort of stuff on the Swift level and then use it at such a high level and get the feedback from Clang. And I found that really interesting. And I guess it's also a look into the future, what might be possible with other instrumentation like that, you know, that you can then expose in macros, give you really powerful tools to say, right, this is a critical section in my app. I can't have this block. And I can think of lots of industries where that's super interesting. I mean, there's obviously other programming languages that have that as a feature. There's real-time operating systems that have that as a feature. But I mean, this is a part of that story, right? Swift as a really powerful and safe language, and you can sort of, I guess, in certain ways, get part of that feature set and pull it into a Swift application via that route. Super interesting, I thought.
Yeah, absolutely. Fascinating. My next package is in contrast to my previous package, which was the one that I said it's the kind of thing which is kind of easy to remove if you ever need to. This one is a package that I really like the look of. It's called Swift File by Pelagornis, and it's basically a refinement of the API in Swift for accessing, creating, writing to, reading from files on disk. And I've always found those APIs a little awkward to use, both in Swift and in Objective-C, because they're ultimately calling the same functions. And I know they have got much better since the adoption of Swift, but I still find them a little clunky to use in certain cases. And what this does is it gives a real streamlined, super concise API to create files. So you can, for example, call a create file function. You can call file.write. You can, path.temporary will give you the temporary folder and things like that. So you can really streamline that API code, and I really like that. And I hope that one day Swift and the standard library tweak those APIs, as we all hope that all APIs get easier to use, right? There's no pressing problem there, but it's the kind of thing that could, of course, be improved. But this package, I would be really hesitant to place at the core of any app, because if you're doing a lot of file management stuff, it's likely that code is going to seep into your application in a way that might be difficult to remove in the future. So I really like this package. I think it's kind of interesting to see what this API might look like, but it's one of my traditional it's good, but I maybe wouldn't recommend it packages.
Actually, yeah, we didn't actually have a conflict. You didn't pick the one I thought you might pick.
I've still got one more.
Oh, you still have one. All right, but I started this time around, so I might still.
But I'm fairly confident that it's not going to be my last one is not going to.
Okay, well, let's see. So my third and final pick is Render Me This by Just Ether. That's the username associated with a package.
It was on my shortlist, and my package is by the same author.
Ah, there you go. Fantastic. Nice. So this is a really interesting package. Do you know how SwiftUI is magical in that it detects what has changed in a view model and then updates the UI bits that are affected? And
absolutely, yeah.
You just see it happen, right? You see the UI update and you think, oh, that's fantastic. The problem is it's quite easy to accidentally oversubscribe and then trigger way more changes than required. And that's not something you necessarily easily see, because it might just re-render and it doesn't look that different. And this package is a great tool because it provides both a view builder wrapper as well as a view modifier to render check a view hierarchy. And by render check, I mean is it will sort of flash in red the parts of the UI that have just updated, and sort of flashes red and then gets translucent. It's a really nice effect. If you look at the README, there's a video showing it in action. It's really great. I mean, if you look at the README, you know exactly what it does immediately just by looking at it. And it's so easy to add, right? You just tack on a view modifier, or just wrap it in a view builder if you prefer to do it that way, and then it just works. It does its thing, and shows you what actually is happening, and you can still interact with your app, right? So you can just in the example, there's moving a slider, and then you see like a label is changing, and obviously the slider is changing itself, but you see all the parts of the app that might be affected by this slider at a glance. So I thought that was really great.
Yeah, well, like I say, it was on my shortlist, and I think both of the packages, because my next package is by the same author, as I said, have great README files. They both of them jumped out at me in terms of potential to talk about, and so that's always a good sign. The package I'm going to talk about, though, is called Glow Getter, GLOW Getter, and it is also a SwiftUI package, but it does something really interesting. It kind of enables the HDR mode on your phone, or I guess on your Mac if you have a HDR compatible display on your Mac, and allows views in your SwiftUI view hierarchy to become brighter than they would all normally be able to with standard APIs. So normally, the UI that you create can only become as bright as the screen is currently set to. But if you're doing an HDR image, like if you go into the Photos app, you'll see your phone screen quite visibly brighten when you show a picture that was taken with HDR information in it. And what this allows you to do is apply that as a view modifier to any view with a .glow view modifier, and the strength of the parameter that you pass to that modifier determines how much it's going to glow and kind of stand out. And I've never seen anything like that in terms of SwiftUI view modifiers, but I have seen an app which is kind of similar. And in fact, at the bottom of the README file for Glow Getter, there is an acknowledgement to Geordie Bruin and Ben Haraway, who wrote an app called Vivid, which allows you to take your MacBook HDR display screen and max the brightness even beyond what is kind of standard for the screen, and it does that by enabling HDR mode and then using that to then increase the brightness. And it says that this repository, the GlowGetter repository, adapts some code that was built for Vivid that lets you use your MacBook at the maximum brightness. So I thought it was kind of an interesting package in terms of I've never seen anybody bring this into an environment where it would be this easy to apply to something.
Nice. Beautiful icon too in the README of the GlowGetter icon.
Yeah, really. Yeah.
Nice.
Yeah. So I think it's kind of unheard of, actually, that we have both picked a package by the same author in the same episode. And back-to-back packages by the same author. So Aether is truly the star of this episode.
Absolutely.
Great. Well, let's wrap it up there then, shall we? I think this is actually the first one in a little while that's been bang on schedule. So we are running exactly to our self-imposed clock.
Back on track.
Normal. Back on track, yeah. So you should expect. Here's me confidently saying you should expect another episode in 3 weeks. Let's be confident about it. But until then, we will say goodbye for now, and I will see you next time.
See you next time. Bye bye.
All right. Bye bye.